A small wind turbine can be a perfect complement to a photovoltaic system. But beware, far too often a small wind turbine becomes a bad investment. And why? Because the same mistakes are made over and over again. You will do better because after watching the video, you will know the most common mistakes. I'm Patrick, I'm a neutral expert and author from Germany with a focus on small wind turbines. I've been observing the market for over 10 years now, and the videos on this channel will help you to make your own wind power project a success. First, a few practical examples to give you an idea of typical applications and operators of small wind turbines. This here is a small wind turbine in the garden of a private homeowner. The turbine has a height of 10 meters or 33 feet and a capacity of 2.5 kilowatt. The wind turbine has an inverter so that the electricity can be fed into the domestic grid as AC, this means alternating current. And this small wind turbine here belongs to a small commercial enterprise. The wind turbine has a capacity of 7 kilowatt and is mounted on an 18-meter high mast. Many farmers have good conditions to operate a small wind turbine. This turbine here has a power of 30 kilowatt and has a total height of 50 meters, which is 160 feet. Total height means highest point reached by the rotor. Here we see a very small wind turbine with a vertical rotor axis. And this small wind turbine with only 12 watts is used on a sailing ship to maintain the charge of a battery. And finally, here we see two micro wind turbines with 350 watts capacity each. The wind turbines are used together with solar power modules and batteries. This hybrid system supplies a remote transmission tower with power all year round. What are the key features of small wind turbines? They are installed directly next to or on top of the electricity consumer. The electricity is mainly used for self-consumption. This is usually more economical than feeding it into the public grid. In most countries, there's a very low or even no feed-in tariff for small wind turbines. The key advantage and benefit of small wind turbines? They often produce electricity when the photovoltaic system is not productive. When the sun is not shining, the wind often blows. This is true, for example, in the fall and winter in Europe. The sun is weak and the wind is strong. In other countries, during the rainy season, there's a little sun, but lots of wind. Mistake number one to avoid with small wind turbines: overestimating the wind energy on your own property. It is the most common and serious mistake you can make with wind turbines for self-supply. This means that the perceived wind force is often wrong. One assumes a lot of wind, but the wind is too weak over the year. A wind turbine would generate too little electricity. The important feature of a windy side is a free flow of wind from the main wind direction. So you must know the main wind direction in your region. You can find it out via the Global Wind Atlas. Go to globalwindatlas.info, set the height to 10 meters, check if mean wind speed is selected, set the point approximately at the place where the wind turbine should be installed, select wind power rows, and from the wind rows you can read the main wind direction. In this example, the wind comes from the southwest. So the strong wind flows from the southwest to the northeast. Locations in residential areas are often critical. This is because the wind is blocked by surrounding houses and trees. With an example, I will explain where windy sites as well as unsuitable sites are located. This is a settlement in a flat region. I looked up the main wind direction in the Global Wind Atlas as described earlier. In this case, west is the main wind direction. This means over the year the strong wind flows to a large extent from the west to the east. The properties at the western edge of the settlement, here marked with the red dash, therefore have a free inflow from the main wind direction. And these single sites also have a windy location, as typical for farms. And now please look to the red point in the middle of the settlement. A site in the middle of the settlement is not suitable because in the western direction there are other houses that do stop the strong wind. In addition to locations on the edge of settlements and single sites, also hillsides may be suitable. Mistake number 2 is the use of a mast or tower which is too small. This applies to locations where up to a certain height the wind is too weak or has too much turbulence. So the rotor must be above this height to be in the strong wind. If the mast is too low, the rotor is in weak wind and the power production will be strongly reduced. The rule is, the higher the mast, the stronger the wind. The wind speed increases with distance from the ground. At a height of 30 meters, the wind is usually much stronger than at a height of 10 meters. And a longer tower can pay for itself. A longer tower does cost more money, but the turbine will produce more electricity because of the stronger wind. The extra cost of the tower could be offset by the higher electricity production. This is an individual consideration for each site. Mistake number 3 is the installation of the wind turbine on the roof. Solar panels can be installed on roofs without any problems. This is not the case with wind turbines. The biggest problem is insufficient wind conditions above the roof. The wind is often too weak and has too much turbulence. The closer the rotor is to the roof, the greater the wind turbulence to which the rotor is exposed. Structure-borne sound transmissions are also problematic. Vibrations of the rotor are perceived as disturbing noise within the house. Decisive are the height of the roof as well as the height of the mast above the roof. A high industrial hall could be suitable, a private house usually not. Generally, short masts are problematic because then the rotor is too close to the roof surface and thus in the area with wind turbulences. The better choice is installing the turbine on a ground level mast. Mistake number 4 is do not choose the wind turbine on the basis of the rated power. For photovoltaic system, it's common to select a system based on the power in kilowatt. This is because based on the output, it's quite easy to derive the annual electricity yield in kilowatt hours for the solar system. A wind turbine, on the other hand, should not be selected based on its rated power in kilowatt, since power is only an inaccurate indicator of annual electricity yields. Two wind turbines of the same rated power can have very different annual electricity yields. An example, two wind turbines with a capacity of 10 kilowatt are each located at the same site. One plant produces 10,000 kilowatt hours per year, the other 20,000 kilowatt hours, so twice as much. How can this be explained? The wind turbine with a higher electricity production has a larger rotor. That is, the rated power of the generator is identical, but the rotor are different sizes. So, when choosing a wind turbine, you should look primarily at the size of the rotor and less at the rated power of the generator. So, how to proceed for sizing a wind turbine? When choosing a wind turbine, the first question to ask is, how much electricity should the turbine generate per year? The starting point is your own annual electricity demand, because a small wind turbine is primarily for self-supply. The next step is to find out the average wind speed on your site. And now check manufacturers of small wind turbines. Which turbine generates the desired amount of electricity at the corresponding wind resource of your location? Note the rotor size. Look for wind turbines with similar sized rotors. Mistake number 5 is the selection of the wind turbine mainly according to the optical design, the appearance. The wind turbine that one likes the most visually is chosen. There are very different rotor types for small wind turbines. Basically, a distinction is made between horizontal and vertical wind turbines. Here on the left, we see a wind turbine with a horizontal rotor axis, and this type is state of the art. On the right, a wind turbine with a vertical rotor axis. In practice, there are many variants. Small wind turbines can really look very different. On the left, a horizontal wind turbine with 3 blades and a wind vane. On the right, a so-called shrouded or ducted wind turbine. This design has not been convincing so far. And now on the left, we see a vertical Dario rotor, and here on the right, a vertical Savonius rotor. The Savonius design has low efficiency. A good rotor design is primarily characterized by high efficiency. This means high power production. One should choose the wind turbine that produces the most electricity at one's own location. Market practice has shown that fancy-looking small wind turbines often result in low electricity yields. State-of-the-art are still the usual turbines with horizontal rotor axis. For each type of wind turbine, you have to find out how much electricity does the turbine generate at my location, and what are the total costs of the turbine. Costs and revenues should be in reasonable proportion. Mistake number 6. Neglecting independent references on a small wind turbine. This means blindly trusting the information provided by the supplier. A problem worldwide for years. There are great differences in the quality of small wind turbines offered on the market. On the one hand, there are many excellent manufacturers with efficient and storm-proof turbine technology. Such small wind turbines have been extensively tested before market launch. The downside of the market is the high number of questionable manufacturers with low-quality products. If you are interested in a specific wind turbine, ask yourself, what independent references are there for the turbine? This can be, for example, a certification based on the IEC 61400-2 standard. The results of test fields are also helpful. The test field operators should be independent. The tests include, for example, the power curve and sound level. If possible, you should look at a small wind turbine on site, preferably on a windy day when the turbine is in operation. Talk to the owner of the wind turbine and learn from his experience. If you don't want to miss future videos, subscribe to this channel. And if you have any questions about small wind turbines, please post in the comments below. Thanks for watching.